On the 2nd of April, 2026, the night silence over the coast of Florida was torn apart by a roar that was heard for tens of kilometers. The most powerful rocket in human history, the Space Launch System, lifted off from Launch Complex 39A of the Kennedy Space Center. On board, 4 astronauts began a journey that we have been waiting for over 50 years. Official reports from the National Aeronautics and Space Administration dryly describe the Artemis II mission as testing the systems of the Orion spacecraft in deep space. But are we truly spending tens of billions of dollars just so that 4 people can fly around the moon and return back? The true essence of this mission is much deeper. We are in the epicenter of not just a scientific experiment, but a fundamental redistribution of outer space. While you watch this video, the spacecraft is covering thousands of kilometers of deadly radiation in the Van Allen belts, heading to the point where the influence of the magnetic field of the Earth ends. What is truly behind this return? Why have the leading nations of the world started a new lunar fever exactly now? And what secret does the south pole of our satellite hide that forced scientists to rewrite astrophysics textbooks? Today, we will look behind the scenes of official press releases, analyze the physics of incredible loads, and learn the truth that stands behind this epic journey. This is not just a mission. It is the beginning of the transformation of humanity into an interplanetary species. To understand the true importance of the events of the 2nd of April, 2026, we must return to December 1972. At that time, Eugene Cernan, the commander of the Apollo 17 mission, left the last footprint of a human boot in the lunar regolith. For decades, the moon seemed to us a completed stage, a dead stone ball where we had already seen everything worth seeing. The Apollo program was a child of the Cold War, a political sprint whose goal was to prove the technological superiority of one superpower over another. As soon as the flags were planted and soil samples were delivered to the Earth, funding ceased and interest faded. However, science does not stand still. While people were locked in low Earth orbit, flying aboard the International Space Station at an altitude of only 400 kilometers, robotic probes continued to explore the moon. A true tectonic shift in our understanding of the satellite occurred in 2009. At that time, the L.C. Ross mission performed a controlled crash of the upper stage of a rocket into the Cabeus crater located at the south pole of the moon. Analysis of the raised dust revealed a sensation. In the shadowed regions, where sunlight has not reached for billions of years, there is water ice. Official data from the LIND instrument, installed on the Lunar Reconnaissance Orbiter, confirmed that hundreds of millions of tons of water are hidden on the moon. This discovery instantly changed the status of the moon from an object of scientific curiosity to a strategic asset. Water is not just a liquid for drinking. It is hydrogen for rocket fuel and oxygen for breathing. Whoever controls the ice on the moon controls the path to the entire solar system. The Artemis program, named after the twin sister of Apollo, symbolizes a new philosophy of exploration. If Apollo was about visiting, then Artemis is about staying. The Artemis I mission, which took place in 2022, was a successful test of the rocket and spacecraft without a crew. However, it is Artemis II that is the critical moment when we test the human factor in deep space. The 50-year pause in flights was caused not only by a lack of money, but also by a technological challenge. Modern computer systems are much more complex than those used in the 60s, but they are also more vulnerable to space radiation. The current context of the mission is defined by the concept of global moon exploration, supported by more than 30 countries within the framework of the Artemis Accords. However, behind the diplomatic formulations stands fierce competition. The People's Republic of China is actively deploying its Chang'e program, aiming to create its own base on the moon by 2030. Therefore, the flight of Reid Wiseman and his team is not just a scientific mission. It is a geopolitical statement. We are returning to the moon to establish international standards for the use of its resources. This is a historical milestone where the era of observations ends and the era of industrial space exploration begins. When the Space Launch System rocket lifted off from the launch pad on the 2nd of April, 2026, It activated the most powerful engine architecture that humanity has ever created. Four main RS-25 engines, previously used in the Space Shuttle program, working together with two giant solid rocket boosters, created a total thrust of 8.8 million pounds. This is 15% more than the legendary Saturn V. But the physics of this launch is only the first step. A true scientific laboratory unfolds in space, inside the Orion spacecraft. One of the most difficult technical challenges of the Artemis II mission is overcoming the Van Allen radiation belts. These are zones around the Earth where the magnetic field of our planet holds high-energy charged particles flying from the Sun and from deep space. The Orion spacecraft passes through these belts twice. To protect the crew, engineers developed the Hybrid Electronic Radiation Assessor System. This is a network of sensors scattered throughout the cabin that measure the flow of protons and heavy ions in real time. In the event of a solar flare, the astronauts have orders to move to the central part of the spacecraft, where the walls of the cabin are supplemented with massive containers of water and food supplies. The hydrogen contained in the water and products is one of the best natural barriers to space radiation. However, the heart of the spacecraft is the European Service Module, provided by the European Space Agency. It contains 33 engines of various power and a thermal regulation system. As the lead engineer of the project, Philippa Moreau explains, "This module is what supports life in conditions of absolute vacuum and temperature fluctuations from -150 to +150 degrees Celsius. The system for air regeneration and carbon dioxide removal is an improved version of the systems operating on the International Space Station, but it is much more compact and reliable." One of the most intriguing scientific experiments on board is the testing of the Artemis II optical communications system, abbreviated as O2O. Instead of traditional radio waves, this device uses infrared laser radiation. This allows for the transfer of data at a speed of up to 260 megabits per second from a distance of 400,000 kilometers. This is a scientific breakthrough. We can transmit high-definition video in 4K format from the vicinity of the Moon in real time for the first time. As Dr. Elizabeth Kendall from the Jet Propulsion Laboratory states, this technology will become the foundation for a future space internet, without which the construction of a stable base on the surface of the satellite is impossible. The scientific base of the mission also includes unique research in the field of space biology. Since the human body in deep space is subjected to the influence of microgravity and radiation simultaneously, the astronauts are conducting the BioSentinel experiment. Special microfluidic cartridges contain living yeast, the genetic code of which is very similar to the human code in terms of DNA repair mechanisms. By observing how yeast reacts to damage from space rays, scientists obtain invaluable data on how to prevent oncological diseases and tissue degradation in humans during long flights to Mars. The flight trajectory of Artemis II is a masterpiece of astrodynamics in itself. The mission uses a so-called high ellipticity orbit with a rotation period of 24 hours. During the first day after the launch on the 2nd of April, the crew remains in this orbit to check the environmental control and life support system. Only after all systems confirm their functionality is the trans-lunar injection maneuver performed. This requires perfect precision. An error of 1 second in the operation of the engine can lead to a miss of the Moon by thousands of kilometers. The application of the law of universal gravitation of Isaac Newton and the general theory of relativity of Albert Einstein allows the spacecraft to use a free return trajectory. This means that the gravity of the Moon will act like an invisible hand that will pick up Orion, turn it 180 degrees, and direct it back to the Earth without the need to turn on the main engine for the return journey. This is the safest flight method, which minimizes risks in case of a power plant failure. When the spacecraft approaches the Moon at a minimum distance of about 10,300 kilometers, it will move at a speed of over 2,000 meters per second. At that moment, the astronauts will conduct visual observation of potential landing sites at the South Pole using cameras of ultra-high resolution. The true essence of this deep dive is the transformation of theoretical models developed on the Earth into practical survival experience. Every liter of water recycled by the system and every watt of energy obtained from the solar panels of the spacecraft is proof that a human is ready to challenge the boundless darkness. Despite the flawless launch on the 2nd of April 2026, the scientific world is not monolithic in its views on the strategy of space exploration. Around the Artemis II mission and subsequent plans, sharp scientific discussions take place that often go beyond official press releases. The true essence of the question is not whether we can return to the moon, but whether the chosen path is the most rational for humanity. One of the most discussed topics is the concept of the Lunar Gateway, an orbital station that is intended to become a permanent hub in lunar orbit. Some leading planetologists and engineers, such as Robert Zubrin, the founder of the Mars Society, put forward an alternative theory. They argue that the construction of a station in the orbit of the moon is a redundant complication, a kind of space customs that only consumes resources. In their opinion, direct flights from the orbit of the Earth to the surface of the moon, as was done in the Apollo program, would be much more efficient. However, the National Aeronautics and Space Administration justifies the necessity of the gateway through the prism of orbit physics. The station will be placed in a unique balance point of the gravitational forces of the Earth and the Moon, where the station can remain for decades, spending a minimum amount of fuel. This orbit provides constant direct communication with the Earth and ideal access to the south pole of the Moon, which would be impossible when using the low equatorial orbits of the past. Another scientific puzzle facing the crew of Artemis II is the so-called mascons, or mass concentrations under the lunar surface. These are anomalous zones with extremely high density that distort the gravitational field of the Moon. They were first discovered in the 60s, but only now, thanks to data from the Grail mission, do we understand their nature. They are giant underground reservoirs of solidified lava at the sites of massive asteroid impacts. During the flight, Orion passes through these gravitational pits, and the precise measurement of their impact on the spacecraft trajectory is critically important for future automatic landings. Professor Jeffrey Andrews Hanna from the University of Arizona emphasizes that without a detailed understanding of the mascons of the South Pole, a safe landing of heavy cargo modules will be mathematically impossible. Special attention in scientific circles is paid to transient lunar phenomena. These are mysterious flashes of light or clouds that amateur astronomers have observed on the surface of the Moon for centuries. For a long time, this was considered conspiracy theory, but modern science gives a rational explanation. Research published in the journal Planetary and Space Science suggests that these are gas emissions, such as radon or helium, from deep faults in the lunar crust, or the electrostatic levitation of ultrafine lunar dust under the influence of the solar wind. The crew of Artemis II is equipped with spectrometers that will allow them to record these processes up close. This is important because such gas emissions may indicate the presence of tectonic activity, which is a critical factor when choosing a site for the construction of a future base. Speaking about the future, Artemis II is the foundation for the Artemis III mission, where for the first time in history, a woman and a person of color will descend to the surface of the Moon. But here another scientific discussion arises regarding the transport system. The National Aeronautics and Space Administration chose the company SpaceX to create a landing module based on the Starship rocket. This decision is revolutionary because Starship is dozens of times larger than any previous landing module. Some experts fear that such a huge construction during landing could raise such an amount of dust that it would enter the orbit of the Moon and create a danger for the Gateway Station. The true essence of the mission of the 2nd of April is to collect data on the structure of the regolith at the South Pole, to understand how the surface will react to a jet stream of such power. No less important is the Viper project, a robotic lunar rover that will go to the South Pole shortly after the return of Artemis II. Its task will be to literally drill for ice in dark craters. The world of scientists is currently arguing, is this ice pure water, or is it a mixture of ammonia, methane, and carbon monoxide? If the ice turns out to be too contaminated, the technology for processing it into fuel will become significantly more expensive. The astronauts of Artemis II, flying over the Shackleton crater, use laser altimeters to create a micro-relief map that will help Viper not to get stuck in the lunar darkness. Finally, we must mention the Mars connection. The official strategy sounds like from the Moon to Mars. Dr. James Garvin, the chief scientist at the Goddard Center, explains that the moon is an ideal testing ground. Here, we will test kilopower nuclear reactors, which will provide the base with energy during long lunar nights that last over 350 hours. We will test 3D printing of houses from lunar regolith. But most importantly, we will study how the human brain and immune system react to deep space for a long period. The Artemis II mission is the first measurement of the intensity of space rays on living humans outside the magnetosphere in an era of high solar activity. The data of this flight will determine whether we can reach Mars at all or if the radiation barrier will remain insurmountable for our biology. Thus, alternative views and future plans show that we are at the stage of a great experiment. Every decision, from the choice of orbit to the construction of spacesuits, is subjected to strict criticism and verification. But it is in this collision of ideas that true science is born. We are not just flying to the moon, we are creating a new branch of knowledge: planetary engineering. While the Orion spacecraft overcomes the infinite void on the way to our natural satellite, inside the cabin with a volume of only 9 cubic meters, the largest biological experiment in modern history is taking place. The true essence of the Artemis II mission, which began on the 2nd of April, 2026, is to answer a fundamental question. Is the human body capable of enduring a long stay outside the protective magnetic field of the Earth? Up to this point, all our data on the impact of space on the organism were based on flights to low Earth orbit, where the magnetosphere of the planet still deflects up to 90% of dangerous space radiation. The crew of Artemis II became the first in the 21st century to face the ionizing radiation of deep space face-to-face. A scientific report titled "Health Risks to the Crew in Missions Beyond Low Earth Orbit," published by the Institute of Space Medicine, emphasizes the danger of so-called galactic cosmic rays. These are high-energy atomic nuclei that arrive from distant supernova explosions. Unlike solar protons, from which one can hide behind thick walls, galactic rays possess such colossal energy that they pierce the metal skin of the spacecraft, creating secondary radiation. Astronaut Victor Glover and his colleagues are participating in the study Biomarkers of Radiation Exposure. They collect samples of their own biological fluid daily, which will be frozen and delivered to the Earth for deep genetic analysis. Scientists are looking for specific microscopic damage in the chromosomes of lymphocytes, to understand how quickly the body begins to lose its ability to regenerate tissues under the influence of space particles. However, radiation is only part of the challenge. Another critical problem is neuropsychological stability. On board Orion, a unique experiment is conducted to study cognitive performance in conditions of extreme isolation. 4 people are in a confined space the size of a small kitchen for 10 days. A specialist in space psychology, Dr. Lawrence Palinkas, notes that in such conditions, the phenomenon of detachment from the Earth arises. When our home planet turns into a small blue dot that can be covered by the thumb of a hand, a deep sense of vulnerability and alienation can arise in astronauts. The crew uses special tablets with software for daily testing of reaction speed and psycho-emotional state. These data are invaluable for planning future 3-year flights to Mars, where isolation will be measured in months and years, and communication with the Earth will have a delay of up to 20 minutes. Another aspect that is rarely discussed in popular media is the impact of microgravity on the redistribution of fluid in the body. In a state of weightlessness, blood and lymph rise to the upper part of the body, creating the so-called puffy face effect. This is not just a cosmetic problem. Increased intracranial pressure can lead to a change in the shape of the eyeball and worsening of vision, a syndrome known as spaceflight-associated neuroocular syndrome. Christina Koch, who already has experience staying in orbit for 328 days, conducts measurements of the pressure inside the eyes using a portable tonometer. This helps scientists understand how quickly these changes occur during short but intense flights to the moon. The scientific group of the mission also pays huge attention to the microbiome of the spacecraft. In the conditions of a closed ventilation system, bacteria and fungi can evolve much faster than on the Earth. The monitoring of the microbial environment experiment involves the regular collection of swabs from the surfaces of the cabin and touch panels. Scientists from the Jet Propulsion Laboratory seek to ensure that the cleaning systems of Orion are capable of effectively filtering not only carbon dioxide, but also potentially dangerous pathogens that could harm the health of the crew at the most distant point of the route. The true essence of this biological section is that Artemis II is a test of our ability to remain human in an environment that is absolutely hostile to life. We are studying the limits of human endurance. As the chief scientist of the National Aeronautics and Space Administration, James Free, states, "We cannot become an interplanetary civilization until we learn to protect our biology as reliably as we protect our computers." Every minute of the Artemis II flight is a giant array of data that will allow future generations to feel in space not as in a deadly trap, but as in a new home. As we observe the flight of Artemis II, which began on the 2nd of April, 2026, we must realize that this is not just a scientific journey. It is the beginning of a new economic era. The true essence of what stands behind this mission is hidden in the concept of space geopolitics. If the 20th century was an era of struggle for oil, then the 21st century will become an era of struggle for the resources of the moon. And in the center of this struggle is the South Pole, a territory that scientists call the most valuable real estate in the solar system. The first and most important resource that forces the leading nations of the world to invest billions of dollars is helium-3. This is an extremely rare isotope on the Earth, but on the Moon, its reserves are estimated at millions of tons. Helium-3 is considered an ideal fuel for future thermonuclear reactors. Unlike traditional nuclear fission, thermonuclear fusion using helium-3 does not create dangerous radioactive waste. According to calculations by specialists from the Massachusetts Institute of Technology, only 25 tons of helium-3 could provide the energy needs of the United States of America for an entire year. The moon is a giant energy battery, and whoever first learns to extract this resource will gain control over the world economy for centuries to come. However, the economy of the moon is based not only on energy. Lunar regolith is rich in rare earth elements such as neodymium, yttrium, and lanthanum. These metals are critically important for the production of modern electronics, from smartphones to electric vehicle engines and rocket guidance systems. Currently, the vast majority of these resources are controlled on the Earth by one state, China. Therefore, creating an alternative supply chain through extraction on the moon is a matter of national security for many countries. Here we approach the legal aspect, which is as complex as the physics of flight. The Outer Space Treaty of 1967 prohibits any state from declaring sovereignty over celestial bodies. However, the Artemis Accords, signed by over 30 countries, introduce a new concept of safety zones. Officially, these are zones around lunar bases to prevent interference in activities. But critics and legal experts, particularly from the International Institute of Space Law, warn that de facto this could become a mechanism for the privatization of sections of the moon. The true essence of the mission of the 2nd of April is to claim a place for future infrastructure, while international law is still trying to catch up with technological progress. We must also consider the role of the private sector. The Artemis II mission is the culmination of a public-private partnership. Giants such as the Lockheed Martin Company, which created the Orion capsule, and the SpaceX Company, which is developing the landing module, receive not only money but also invaluable intellectual rights to technologies. A report by the Morgan Stanley Banking Group predicts that the volume of the space economy by 2040 will reach $1 trillion. The moon is becoming part of the economic sphere of the Earth. The strategic military significance cannot be ignored either. In military science, there is the term high ground. The moon is the highest point in the Earth-Moon system. The placement of observation systems or communication hubs on the moon or at Lagrange points, places where the gravity of the Earth and the moon is balanced, gives a colossal strategic advantage. Although the Outer Space Treaty prohibits the placement of weapons of mass destruction in orbit, control over cislunar space, the space between the Earth and the moon, is becoming a priority for the space forces of many states. Competition with the People's Republic of China is the main driver for the acceleration of the Artemis program. The Chinese Chang'e program has already proven its effectiveness by performing the first-ever landing on the far side of the moon and successfully delivering soil samples to the Earth. China, together with the Russian Federation, announced the creation of the International Scientific Lunar Station, which is a direct alternative to the Artemis Accords. Thus, we are observing the formation of two space blocks. The Artemis II mission is a demonstration of the capability of the democratic bloc under the auspices of the National Aeronautics and Space Administration. All this leads us to the concept of in situ resource utilization, or ISRU. This is the technology for processing lunar ice into fuel right on the surface. Without this technology, any expansion into deep space will be economically impossible due to the huge cost of lifting every kilogram of fuel from the gravitational pit of the Earth. The true goal of the flight of the 2nd of April is to ensure that the Orion spacecraft can become part of this future logistical network that will connect the Earth, the Gateway Orbital Station, and the surface of the Moon into a single transport system. We are not just flying to the Moon. We are building the first railway track into infinity, where every station is a source of energy and new knowledge. We have come to the finale of our journey, but for the crew of Artemis II, the true story is only beginning. Looking at the majestic silhouette of the Orion spacecraft returning to the Earth after a 10-day journey, we must realize that what we saw on the 2nd of April, 2026, was something bigger than just a technical achievement. It was an act of defiance against the laws of nature that for millions of years kept our species on one planet. The true essence of the Artemis II mission is not water ice, not helium-3, and not even the race with other states. It is a test of our maturity as a civilization. Over the last 50 years, we have learned to live in the orbit of the Earth, but we remained under the warm wing of its magnetic field and atmosphere. Now we have stepped into the real, hostile, and majestic universe. We have proven that we are capable of creating technologies that protect fragile human life from radiation, vacuum, and extreme temperatures. As the prominent astrophysicist Carl Sagan once said, "We are made of star stuff, and we are a way for the universe to know itself." The mission of the 2nd of April is a way for the universe to open its eyes again in the darkness. The philosophical conclusion of this mission is that the Moon is not the final stop but a gateway. It is a training ground before the jump to Mars. Every liter of water extracted at the South Pole and every kilowatt of energy obtained from solar panels in lunar orbit bring us closer to the moment when the first human steps onto the red sand of Mars. Artemis II laid the foundation for this future. It showed that dreams of an interplanetary humanity are not science fiction, but a clear engineering plan that is being realized before our eyes. Summarizing the scientific results, we can say with confidence that the data collected during this flight will change medicine, materials science, and physics. Water purification technologies developed for Orion are already finding application in the most arid regions of the Earth. Laser communication systems will become the basis for global networks of the future. Research on the impact of radiation on the genetic code of astronauts will help us better understand the mechanisms of aging and the fight against oncological diseases. Space always returns investments 100-fold, even if these dividends do not come in the form of money, but in the form of saving lives on the Earth. We live in a unique time. We are the Artemis generation. We are the ones who see how history goes beyond the Earth's crust. But this path requires not only money and technology, but also your support. Science is not something that happens somewhere far away in the laboratories of the National Aeronautics and Space Administration. It is our shared intellectual path. It is our curiosity that forces us to ask questions about the stars. How do you see the role of humanity in space in 50 years? Will we be inhabitants of many planets, or will we remain only observers? Are these colossal efforts justified when there are so many problems on our own planet? Share your thoughts in the comments. Your reflections are part of the very same dialogue that humanity has been conducting with the universe since the first human looked at the night sky and asked, "And what is next?" Do not forget to subscribe to our channel and like the video so that we can continue to tell you about the greatest adventures of our species. We will follow every step of the Artemis program, every landing, and every new discovery. Thank you for being with us on this journey to the stars. Remember, infinity is only the beginning.